Hey guys, this is Fraser. Thanks for tutoring. Today we're looking at this 2021 November paper 1. It's from the HL exam, but all of the content is also should also be fine for the SL students. So it's a 7-mark question. First part is 5 marks, and honestly I think it's pretty generous all you have to do. It's not super difficult. So for the amount of marks that you get, it's not a very difficult question, and the ideas behind it actually pop up all over the place. So it's a good question to look at. So what they're asking us to look at this equation here, which is a quadratic in terms of p, and they've given us that has 2 real distinct roots. And then from that information we have to find the possible values of p. So my question is, how do we know, or what does it mean when something has 2 real distinct roots? So what that means is that if it has 2 real distinct roots, we can do a little drawing over here on the left. So if these are the axes and it has 2 real distinct roots, that means that it doesn't sit on the axis, it doesn't sit above, but it at some point goes below like this, right? Because it has 2 real roots. So these would be the 2 real roots. And we know that the discriminant tells us this, right? So the discriminant is, I usually write it as capital, because sometimes they give a quadratic and the coefficients are in terms of a, b, and c, so the capital less than nice. We know that if it's less than 0, then it has 0 real roots. If it's equal to 0, then it has 1 real root, or repeated roots. So I guess you could say it does have, technically it has 2, but they're repeated, and then if it's greater than 0, it has 2 real distinct. And that third case is the one that we're interested in, right? Because they've given us as 2 real distinct roots. So the middle case, when it's equal to 0, I guess, technically I think it does have 2 real roots, but they're like repeated. Right, because it just touches the x-axis once, just touches it like not like that, but just like that. Okay. Okay. So that means, let's just keep it in mind that we're interested in this last case. So I'm going to erase the other one so we have a bit more space. And then we need to just move this around because we want it to be equal to 0, right? So that means that 3px squared plus 2px plus 1 minus p is equal to 0. So that means that the b, the coefficient of x, is 2p, a is 3p, c is 1 minus p. So b squared minus 4ac is going to be 2p squared minus 4 times a times c. We know this is going to be greater than 0. So that's 4p squared minus 12p 1 minus p, 0, 4p squared, that's going to be minus 12p plus 12p squared. Okay, it's greater than 0, so that means I'm just going to do the writing. I don't know if I have enough space, so it's going to be 16p squared minus 12p. We can factorize the factor of, actually we can divide everything by 4, it becomes 4 and 3, we can factor out a p, 4p minus 3, and so I'm just going to put this, actually I'm going to be a little bit cheeky, I'm going to move everything down, because I don't want to erase any writing, because then it might not be clear exactly what we did, so I'm just going to move that down like that so we got a bit more space. So we're in this case, I'm just going to close that box again. So 4p minus 3 is greater than 0. So that means that we have a product of 2 things is greater than 0. So that means either both products are less than 0, or both products are greater. Now, that's one way of thinking about it. There's actually a simpler way. If we think of this, again, if we think of p as now quadratic, right, it has roots, it's a positive quadratic, 4p squared minus 3p, and it has roots at 0, because when p is equal to 0, and it has roots at 3 over 4, right, because then this is 0. So 3 over 4. It's a positive quadratic. And so we can see the segments that we're interested in are these segments, because on these values of x, it's positive. In between, it's negative. So that means all we need to do is go p is either less than 0, in which case both of them are negative, or p is greater than 3 over 4. And notice that it's a strict inequality, because if it would be equal, then the discriminant would be equal to 0, which means that we would only have one real root. So hopefully that's clear. You draw a little, I always like drawing little diagrams. You draw a little diagram and you think about which parts of the graph you're interested in. We're interested in this one and this one, because that's when it's positive, and then, yeah, and that happens at these values. You could also do this both negative, both positive, but it's a little bit more complicated. Okay, so we found our, I guess I'll rewrite it in a bit nicer. So p is either greater than 0 or p is less than 0, or p is greater than 3 over 4. So those are our range of values of p. Now they tell you to consider the case p is equal to 4, which is in this end, right? It's greater than 3 over 4. So the roots of the equation can be expressed in this form: x equals a plus minus root 13 over 6, where a is an integer. Find the value of a. This is 2 marks. Literally, all you have to do is just apply the quadratic formula. So now if we consider the case that p is equal to 4, our quadratic becomes 12 p, sorry, what am I doing? Not 12p, 12x squared plus 8x, and then plus 1 minus 4 is going to be minus 3 is equal to 0. And then we literally just apply the quadratic formula. X is equal to minus b, so minus 8 plus or minus the square root of 8 squared, so 64, minus 4ac over 2a. So that is, of course, it's a paper 1, so no calculator. 64, and then this part is going to be so plus 4 times 4 is 12. 12 times 12 is 144 over 24. So that's minus 8 plus or minus, and then this is going to be root 208 over 24. Now I guess the question is, what factor can we pull out? So can we divide it by 4? Yes, we can, because that's going to be 52, right? So minus 8 plus or minus. So 208, so let's do a quick note, is 4 times 54, right? Because it's, yeah, that's going to be, no, 4 times 52, sorry, which is 8 times 26. And we need it in which form exactly? We need it as root 13. So that means we can divide that again. So 16 times 13. So that's a nice way to factorize things if you're not quite sure. You find some lower power. Then all I did is I doubled this one, and I divided this one by 2. So the product is still the same, but we now have it as this. So that becomes root 16, root 13 over 24. I'll just move this around. I don't like deleting stuff because who knows what you might need. I'll put that just like over there as a quick note. So that becomes minus 8 plus or minus 4 root 13, 24. Everything has a factor of 4, so x equals minus 2 plus or minus root 13 over 6, which is exactly what we had to find it in the form of. So that means that a is equal to minus 2. So not too bad. I don't know. The marks here, let me know in the comments, but I think that the marks for this question are quite a lot for what you have to do. All you have to know, and this comes up a lot, is that when they've given you, when you're analyzing the number of roots to a quadratic, the discriminant is going to be your friend. So you have to use the discriminant. And then obviously for the second one, just a quadratic formula. So hopefully this was helpful. Wasn't too bad of a question, but it was still useful to do. And yeah, if you guys feel like you need a bit more help with your math studies, or other studies in general, physics, economics, just any subjects that you feel you might need help with, feel free to head over to Think Smart Tutoring. The link is in the description, both the international and the Dutch website. You can grab a tutor there. It's very flexible. You can set up your own timetable when you'd like to do lessons, how many, how frequently. Obviously, the tutors have recommendations, but it's really up to you as the student to decide. But yeah, I'll be making more of these videos. Let me know in the comments if there are any particular topics you want me to cover. And yeah, see you guys soon.